Hello everyone, good evening. In the last lecture, I have explained about a OSI reference model. This model was a theoretical model and it was having 7 layers and it was a protocol independent standard. And no practical model was existed based upon this theoretical model. That's why a TCP/IP reference model has been developed. This model around which the internet is developed, it has got 4 layers and it is a protocol dependent standard. TCP/IP means Transmission Control Protocol and Internet Protocol. It is the network model used in the current internet architecture as well. Protocols are a set of rules which govern easy possible communication over a network. These protocols describe the movement of data between the source and destination, or the internet. These protocols offer simple naming and addressing schemes. The internet is a collection of networks. The term internet applies to this entire set of networks. Like most networking software, TCP/IP is modeled in layers. This layer representation leads to the term protocol stack, which refers to the stack of layers in the protocol chute. It can be used for positioning the TCP/IP protocol chute against other network softwares like Open System Interconnection model. By dividing the communication software into layers, the protocol stack allows for division of labor, ease of implementation and code testing, and ability to develop alternative layer implementations. Layers communicate with those above and below via concise interfaces. In this regard, a layer provides a service for the layer directly above it and makes use of services provided by the layer directly below it. For example, the IP layer provides the ability to transfer data from one host to another without any guarantee to reliable delivery or duplicate suppression. TCP/IP is a family of protocols. A few provide low-level functions needed for many applications. These include IP, TCP, and UDP. Others are protocols for doing specific tasks, example, transferring files between computers, sending mails, or finding out who is logged in on another computer. Initially, TCP/IP was used mostly between mini-computers or mainframes. These machines had their own disks and generally were self-contained. The first layer is the network interface layer. The network interface layer, also called the link layer or the data link layer or host network layer, is the interface to the actual network hardware. This interface may or may not provide reliable delivery and may be packet or stream oriented. In fact, TCP/IP does not specify any protocols here, but can use almost any network interface available, which illustrates the flexibility of the IP layer. Examples of such protocols have been shown in the diagram. The next layer is the internet layer. The internet layer, also called as the internet layer or the network layer. It provides the virtual network image of an internet. This layer shields the higher levels from the physical network architecture below it. Internet protocol is the most important protocol in this layer. It is a connectionless protocol that does not assume reliability from lower layers. IP does not provide reliability, flow control, or error recovery. These functions must be provided at a higher level. IP provides a routing function that attempts to deliver transmitted message to their destination. A message unit in an IP network is called an IP datagram. This is the basic unit of information transmitted across TCP/IP networks. Other internet network layer protocols are IP, ICMP, IGMP, ARP, and RARP, and so on. The third layer is the transport layer. The transport layer provides the end-to-end data transfer by delivering data from an application to its remote peer. Multiple applications can be supported simultaneously. The most used transport layer protocol is the Transmission Control Protocol, which provides connection-oriented, reliable data delivery, duplicate data suppression, congestion control, and flow control. Another transport layer protocol is the User Datagram Protocol. It provides connectionless, unreliable, best effort service. As a result, applications using UDP as the transport protocol have to provide their own end-to-end integrity, flow control, and congestion control if desired. Usually, UDP is used by applications that need a fast transport mechanism and can tolerate the loss of some data. The last layer in this TCP/IP model is the application layer. The application layer is provided by the program that uses TCP/IP for communication. An application is a user process cooperating with another process, usually on a different host. There is also a benefit to application communication within a single host. Examples of applications include Telnet, File Transfer Protocol, and so on. The main merits of this TCP/IP model is it operated independently, it is scalable, it's a client-server architecture, it supports a number of routing protocols, and lastly, it can also be used to establish a connection between two computers. Demerits of this TCP/IP model is, in this, the transport layer does not guarantee delivery of packets. The model cannot be used in any other application. Replacing protocol is not easy. And last one is, it has not clearly separated its services, interfaces, and protocols as it was done in a OSI reference model. The main difference between a OSI reference model and a TCP/IP model are, as we see in the figure, presentation and session layers are not there in the TCP/IP model. Also, note that the network access layer in TCP/IP model combines the functions of a data link layer and a physical layer. The features that stood out during the research which led to making the TCP/IP reference model are support for a flexible architecture. Adding more machines to a network was easy. The network was robust. Connections remained intact until the source and destination machines were functioning. The overall idea was to allow one application to on one computer to talk to another application running on a different computer using this model. Hope you understood very well about this TCP/IP reference model. Thank you.